Hi everyone, welcome to today's math class. We have this nice polynomial equation before us here. It's a third degree, polynomial equation. The question is m to the power of 3 minus m to the power of 2 minus m equals to 15. What is the value of m that will satisfy this challenge here? All right, so we are made to understand that the highest power of every polynomial tells the number of roots to that polynomial equation. And here we are having a 3 as the highest power, okay? Okay, so how do we get the 3 solutions to this polynomial equation? Yeah, I'm going to use an approach which I found very facilitating to solving this challenge in here. So let's take our solution here. Right, if you see us for the very first time, this is Online Mass TV, and we are always online. We are always releasing videos, and if you not subscribe to our channel. And when you subscribe, do not hesitate to hit the notification button. That is only when you get notified when we release an amazing video, because here we release videos all the time for our learning. Now we have this question in here. Now let's put down our m to the power of 3, then minus m to the power of 2 minus m equal to our 15. Now look at what I did in here. I just have to look at this our 15 here. If I decide to rewrite 15 here in this format, will it work out? Yes. Now, if I decide to put in here 2 to the power of 3 minus 2 to the power of 2 minus 2, would that give us 15? Now, let's check it out. 2 to the power of 3 will give us 8. Then minus 2 to the power of 2 will give us 4. So 4 minus, then 2 to the power of 1 will give us 2, and 2 minus 4 will give us our positive 2. But here we have 15. So that will not work out. If I decide to increase it to 3, let's see if it will work out then. Then we have our 3 to the power of 3 will give us 27. Then we have minus 3 to the power of 2, which is our 9. So give us our 18, positive 18. Then we have our 3 to the power of 1, which is 3. Then will give us 15. Good. So we got an expression of this kind. So we just have to rewrite this 15. And so this is going to give us our m to the power of 3 minus m to the power of 2 minus our m is equal to our 3 to the power of 3 minus 3 to the power of 2 minus 3 to the power of 1. This is good. So the next thing we're going to do here is to move all quantities on the right-hand side to the left-hand side of the equation. And in doing that, we have to move them according to their powers. We're going to marry them according to the powers they have in there. Here we have m to the power of 3. We have 3 to the power of 3. Okay? So from here, we move this and marry it with this. So this is going to give us m to the power of 3. Then this is positive, turns to minus our 3 to the power of 3. There's a reason for bringing them, matching them according to their power. And so we come to this next one, we have minus our m to the power of 2. Then I bring this is negative, so it turns to plus our 3 to the power of 2. Then here I have minus our m, here it turns to positive, so plus our 3, everything equals to 0. Nice. Now I can put this in bracket, put this in bracket, put this in bracket. But putting this in bracket, yeah, this sign will be affected. It will turn to a minus sign, and this will equally turn to minus sign. So let's go ahead and rewrite this. So we have to the power of 3, 3 to the power of 3, or in bracket, then minus bracket m to the power of 2 minus our 3 to the power of 2 close bracket, then minus 3 our m minus our 3 equal to 0. Are we getting something from here? Good. Here we have a difference of 2 cubes, and here we have a difference of 2 square. So what does the law say? For the difference of 2 cubes, it says that if you have your, let's take our x to the power of 3 minus y to the power of 3, this is equal to, bracket open, x minus y, close bracket, bracket, our x to the power of 2, then plus our x, y, then plus our y square, close bracket. This is what we call difference of 2 cube. Then we have difference of 2 square. Difference of 2 square says that if you have your x to the power of 2 minus y to the power of 2, this is equal to bracket open your x, then plus y, bracket, bracket, x minus y. So these are the two algebraic identity we are going to introduce into this system here. So introducing this in here, this is going to give us bracket our m minus our 3 close bracket, bracket, our m to the power of 2, there plus our 3m, there plus our 3 to the power of 2 close bracket, minus. Then we're going to apply difference of 2 square, which is our m plus our 3 close bracket, bracket, our m minus 3 close bracket. Then minus, here we just have our m minus 3 close bracket, everything equal to 0. Easy. All right. So what we do next here now, if you look critically, you discover that from here we have m minus 3. Here we equally have m minus 3. And here we have m minus 3. So what we do when we have situations of this kind, we just have to factor out m minus 3 that is common to all terms. So we're going to have here our m minus 3 close bracket. Let's bring in a square bracket here. If we use this to divide everything here, we are now left with our m to the power of 2 plus our 3m, then plus here we give us our 9 close bracket, then minus. We use this to divide this, we are left with our m plus our 3 close bracket. Then we use this to divide this, we are left with just 1. We close our square bracket, everything equal to 0. So what we do, we can now open the terms we have inside the square bracket in here. So if we open up this is going to give us our m minus our 3 close bracket, then bracket, our m to the power of 2 plus our 3m plus our 9 minus, because we use this minus to open this, so this is going to give us minus m, then minus 3, then minus 1, close bracket, equal to 0. Okay, so let's look at it again. Now, we can add this, and this, and this. Okay, if I add all this together, yeah. So this is going to give us our bracket, our m minus 3 close bracket, okay, bracket. Here we have just m to the power of 2. So we have plus 3m minus m will give us our plus 2m. Then plus 9 minus 3 will give us plus 6 minus 1 will give us plus 5. So we have here plus 5. Everything equals to 0. So let's continue on this side and see what this gives us a 10. Okay. In this regard, we have what is called the zero property. The zero property says that if you have your x times your y equals to 0, it means, or this implies that your either x is equals to 0 or y is equals to 0. This is what we call the zero property. Okay, so if we apply the zero property here, we're going to have the first case scenario and we're going to have the second case scenario. So let's take case 1. So our case 1, we're having our m minus our 3 equals to 0. So if we move this to this side, we have m is equals to 3. So we have our m1 is equal to 3. And if you substitute 3 into the system, you get the answer. It satisfies the original equation. Now, how do we get the other two roots? We're going to get it from this quadratic equation here. So our case 2, we have our m to the power of 2 plus our 2m plus our 5 equal to 0. So in this case, what we do here, we want to use the formula method. So applying the formula method, we're going to have our m is equal to minus b plus minus the square root of our b squared minus 4ac, right, all over 2a. Simple. Okay, so we just have to substitute into the system. If we substitute, this is going to give us our, what is our b? Our b is positive. So this is going to give us plus 2, sorry, minus is going to take minus because we have minus in the system. So we have here minus 2, then plus minus the square root of our 2 to the power of 2, then minus 4 times a is 1, then times our c is 5. Then everything all over 2 times 1. Okay, your dot there is multiplication. Okay, so with this, so what we do is pretty easy. So we're going to have a minus 2 plus minus the square root of, if you check out this, we don't need to multiply this out, okay? But if we do, it will still give us the same thing because here we're going to have 4, so we can factor 4 out of the system, okay? But yeah, let's just go on. So this is going to give us our 4 minus this will give us 20 all over our 2. So let's continue here. So we're going to have here minus 2 plus minus the square root. 4 minus 20, that will give us minus 16. So we have here minus 16 all over 2. Now, we can simplify this minus 16. Let's continue here. We're going to make use of this simple space here. Okay, so the square root of minus 16 can be split into minus 1 times 16. And the square root of minus 1, we know that the square root of minus 1 is equals to iota, right? Good. And the square root of 16 is 4. So we can rewrite everything here. This will now give us our m is equal to our minus 2, then our plus minus our 4 iota all over 2. If we factor out 2 from this, then we're going to have our 2. Okay, let's bring our 2 here. 2 into this will give us minus 1 plus minus our 2 iota all over 2. So this leave the system. So we're going to have our m2 is equal to minus 1 plus 2 iota. And our m3 is equal to minus 1 minus 2 iota. So these are the 3 roots to our challenge. The first one is our m1, which is positive 3. The second one is m2, which is minus 1 plus 2 iota. And the third one, which is minus 1 minus 2 iota. And those are the 3 roots that actually satisfy this polynomial equation, this third degree order polynomial equation. So if you have any question with regards to this question, drop it in the comment section. If you're not clear, also drop it in the comment section. You have a better way of solving this, conserving time. Drop it in the comment section so that Online Maths TV can actually learn from you. Yeah. Okay. Thank you for being there all the time. We love you and we keep loving you until the end of time. Bye. But until we see you in our next class, keep winning.